Beneath the ocean's surface, silent stone cities wait to tell their story. The common explanation is simple, that rising seas from melting ice slowly drowned our ancient coasts. Yet a collection of mysterious sites scattered across the globe refuses to fit that tidy narrative. Today, you will gain a new understanding of history, one where the ground beneath our feet is far less stable than we assume. We will explore 30 submerged ruins that cannot be explained by rising sea levels alone, from structures resting in impossibly deep water to cities found in places the sea should never have reached. What hidden forces sank a metropolis in a single, catastrophic day, and what civilization built monuments half a mile beneath the Caribbean waves? By the end, you will see the map of our past redrawn with questions. What does it mean for our future when the Earth itself can forget its own history? A powerful light cuts through the dark water, revealing a wall of perfectly fitted stone. This is not a reef, not a natural formation. It is architecture resting at a depth where no coastal city should ever have been built. This single image captures the entire mystery. For decades, the dominant story has been one of patience, of oceans slowly reclaiming our shores as the great ice sheets melted over millennia, and for countless ruins that story fits. But then there are the others, the outliers, the sites that defy this gradual timeline and peaceful process. Our journey focuses on 30 specific locations that stand as profound contradictions. To understand why they are so inexplicable, we must first understand the rules they break. The first and most critical rule involves depth. Since the end of the last ice age, global sea levels have risen by approximately 400 feet. This is a well-documented geological fact. Therefore, any structure found submerged deeper than that maximum cannot be explained by rising water alone. It had to sink. The second rule involves location. If a ruin is found in a region known for violent tectonic activity, near a fault line or a subduction zone, its submersion has a ready, if dramatic, explanation. But what of a sophisticated city discovered on a continental shelf deemed stable for hundreds of thousands of years? The Earth did not simply swallow it there by chance. The third rule involves time itself. Some of these submerged complexes display a level of stoneworking and urban planning that, according to conventional history, should not exist in their proposed era. They are technological anomalies found in geographical impossibilities. As scholar Robert Scott has argued, we must move beyond simplistic tales of a single great flood. The real history is likely far more complex, involving what geologists call local land subsidence, where large sections of crust can sink independently of the global sea. This is the key distinction. Eustatic change is the global ocean rising. Isostatic change is the local land falling. Our 30 sites suggest catastrophic instances of the latter, events so sudden and severe they erased entire chapters of human endeavor from the map. So we are left with a haunting question. What immense force beyond the slow creep of water could so decisively and completely place a metropolis beneath the waves? To find clues, we must visit the place where this mystery first captured the world's imagination. Off the southern tip of Japan, the sea holds a secret that looks like a sunken temple. In the clear waters near Yonaguni Island, a diver in the 1980s did not find a shipwreck or a coral reef. He found a vast geometric landscape of stone. The Yonaguni Monument is a colossal structure, or perhaps a formation, that plunges from shallow waters just 16 feet deep down to 100 feet below the surface. Its most striking feature is a giant monolithic platform with a series of near-perfect 90-degree terraces. These are not the gentle, worn slopes of natural rock. They are sharp, clean, and stacked with a rhythm that feels intentional. Surrounding this central terrace are other perplexing features. There is a long, straight roadway that cuts across the seabed. There are two round holes, each about 2 feet wide, that plunge straight down into the rock like ancient column bases. And most haunting of all, there are what appear to be carved faces, one resembling a Moai statue from Easter Island, gazing silently from the stone. For decades, a debate has raged. Is this the world's oldest known pyramid, a relic from a time when this shelf was dry land, or is it a spectacular accident of nature? Leading the charge for a human origin is Professor Masaki Kimura, a marine geologist who has spent thousands of hours studying the site. He points to features that defy simple geology. The terraces have consistent, repeating heights. The stone shows clean, right-angled channels that look like tool marks. One prominent formation, nicknamed the Turtle, is a large, flat rock resting on a raised platform with a distinct head like an altar. Another, called the Star Platform, is a pentagonal shape carved into the top of a pillar. Professor Kimura argues that the natural sandstone in this region does fracture into blocks, but not with this level of symmetry, and not in arrangements that so closely mimic known ancient architecture. The site's layout, with its terraces and apparent plaza, bears a startling resemblance to the foundational designs of stepped pyramids found in cultures across the world, from the ziggurats of Mesopotamia to the first temples of Mesoamerica. Skeptics offer a powerful counter-argument. They say the strong currents and natural fracturing of the sedimentary rock, combined with marine erosion, can create astonishingly regular shapes. The flat surfaces and sharp edges could be the result of the rock splitting along its natural bedding planes. They see a beautiful but entirely natural geological formation. Yet the questions persist, and they are rooted in location and depth. Yonaguni sits on a stable continental shelf, far from any violent tectonic boundary that could have suddenly sunk it. To have been built by human hands, it would have to have been constructed when sea levels were low enough to expose the site. That places its possible origin at around 10,000 years ago, at the very end of the last ice age. This timeline is the true heart of the mystery. If even a fraction of Yonaguni's features are artificial, it suggests a culture with advanced stone working skills existing in prehistoric Japan, a chapter of history completely absent from our textbooks. The monument stands as a profound question mark carved in stone. If this is all a magnificent coincidence of erosion, why does it so persistently, so compellingly, whisper the language of human design? This enigma in the Pacific points us toward an even deeper mystery, one resting in the dark, crushing pressure half a mile beneath the Caribbean sun. The Yonaguni monument rests in the relative shallows, a debate we can almost touch. But far from Japan, in the silent darkness of the Caribbean, a discovery was made that defies any comfortable explanation. In 2001, a team of oceanographers was mapping the seafloor off the western tip of Cuba when their sonar painted a picture that should not exist. Gliding over a vast underwater plateau near the Guanahacoibes Peninsula, their remote-operated vehicle revealed an expanse of structures at a depth between 600 and 750 meters. That is nearly half a mile straight down. The sonar images showed not random rubble, but a sprawling complex of geometric perfection. There were what appeared to be massive, smooth stone blocks arranged in circular and pyramidal forms. There were long, parallel lines that resembled roadways or foundations, and right angles so precise they seemed etched by intent. The entire site covered an area of nearly 8 square miles, a scale that suggested not a village but a planned urban landscape. The lead researchers from the Canadian company Advanced Digital Communication were stunned. Oceanographer Paulina Zelitsky described seeing clear formations of what looked like large structures, possibly built from granite, a stone not native to that part of the ocean floor. The sheer regularity of the shapes, their alignment and repetition, whispered of design, not chance. The immediate and overwhelming challenge is the depth. As we established, the maximum sea level rise since the last ice age is about 120 meters. This Cuban complex is submerged under more than 6 times that amount of water. The only possible conclusion is that this land did not drown from water rising. It sank catastrophically, dragging whatever was on its surface into an abyssal grave. This places its origin in a time so remote it strains conventional timelines. For this plateau to have been above water, we are looking at a period potentially millions of years in the past, a time when, according to mainstream science, no human civilization capable of such megalithic construction should have existed. Skeptics argue forcefully that the human mind is a pattern-seeking machine, and that geology can produce astonishingly regular formations. They point to ancient beach rock that fractures into blocks, or to basalt columns that form natural paving stones. Yet the researchers involved counter that the specific geometries, the 90-degree angles and parallel lines spanning great distances, are exceptionally rare in nature at such a scale and in this specific marine environment. The comparison to other famous submerged cities only deepens the mystery. Places like Egypt's Heracleion or Jamaica's Port Royal are found in shallow coastal waters, exactly where you would expect a harbor city claimed by rising seas or a sudden earthquake. They fit the model. The Cuban megaliths exist in another world entirely, a realm of perpetual darkness and crushing pressure that makes exploration agonizingly difficult and expensive. This lack of physical evidence of artifacts or inscriptions that could provide proof is what keeps the site suspended between legend and potential history. It fuels both extreme skepticism and profound fascination, so we are left with a haunting, reflective question. If this is not a trick of the sonar, what does it represent? What civilization, lost to the abyss of time, could have engineered a city on a landmass that now lies under half a mile of ocean? And what unimaginable geological event could have sent it there, so completely and so finally? From the crushing darkness of the Caribbean deep, our search for answers rises toward the sunlit, legendary waters of the Mediterranean. The clear, sunlit waters of southern Greece offer a different kind of mystery. Here, the ruins are not hidden in abyssal darkness but lie in plain sight just beneath the waves. Off the coast of the Peloponnese, the ancient city of Pavlopetri rests in water so shallow you can swim directly over its stone streets. For decades, it was presented as a classic example of a coastal settlement slowly claimed by the rising Mediterranean over millennia. It seemed to fit the simple narrative perfectly. But recent discoveries have shattered that assumption, revealing a far more dramatic truth. Pavlopetri is not a victim of patient seas, but of sudden, violent earth. Archaeological work led by Dr. John Henderson has meticulously mapped this submerged world, revealing an astonishingly complete Bronze Age city plan. We are not looking at scattered foundations. We see a fully organized urban landscape with distinct neighborhoods, a central plaza, courtyards, and even a sophisticated water management system with channels and drains. This level of preservation is the first critical clue. In a slow, gradual flooding, people have time to leave. They take their valuables, buildings are scavenged for materials, and structures eventually collapse from neglect and erosion. But at Pavlopetri, the story told by the stones is one of abrupt departure. Walls stand upright, some still reaching their original height. Archaeologists found pottery, grinding stones, and other everyday objects still in place, as if the inhabitants simply set them down and never returned. This is not the signature of a retreating coastline. It is the frozen moment of a catastrophe. The geological setting provides the explanation. This region sits near the Hellenic Arc, a highly active subduction zone where the African tectonic plate slides beneath the Eurasian plate. This creates immense geological stress, capable of unleashing powerful earthquakes and causing large sections of land to instantly drop. Research suggests that around 1000 BC, a massive seismic event did exactly that to Pavlopetri. The ground beneath the city subsided, likely in a matter of minutes or hours, plunging its streets and buildings below sea level. The rising Mediterranean waters then flowed in to fill the basin that the Earth had just created. This is the crucial distinction experts make. The sea did rise globally over time, providing the water, but the land fell locally and catastrophically, providing the grave. To understand the scale, consider a more modern parallel: the fate of Port Royal in Jamaica. In 1692, a devastating earthquake struck, and a large portion of that notorious pirate city simply slid into the harbor, submerged almost instantly. Pavlopetri experienced a similar ancient fate, a rapid tectonic drowning superimposed upon a background of slower environmental change. So we must ask a broader, more unsettling question. Pavlopetri, now understood, forces us to re-examine other so-called drowned cities. How many other sites attributed to gentle sea level rise are actually masks for a much more violent geological history? This theme of myth meeting a sudden, earth-shattering reality finds its most powerful expression in a story we all think we know: the legend of Atlantis itself. The legend of a sunken city is not unique to Greece. For over 3,000 years, the sacred texts of India have preserved the memory of a magnificent city claimed by the sea. The Mahabharata and the Puranas describe in vivid detail the city of Dwarka, a divine fortress of gates and palaces built by Lord Krishna on the western coast. The scriptures recount its splendor and ultimately its fate, that after Krishna's departure, the ocean rose and swallowed the great city whole. For centuries, this was considered pure mythology, a spiritual allegory. Then, in the late 1980s, marine archaeologists made a discovery that would blur the line between scripture and history. Off the coast of modern Dwarka in Gujarat, the seabed yielded stone anchors, pottery shards, and the unmistakable foundations of massive walls. These were not isolated finds. They outlined a vast, fortified settlement that extended from the modern shoreline out into the deeper waters of the Arabian Sea. The leader of these excavations, Dr. S.R. Rao, presented evidence of a sophisticated harbor city dating back to the 2nd millennium BC, a time frame that intriguingly aligns with the traditional date of the Mahabharata War. The archaeological Dwarka shows clear signs of a prosperous maritime culture, one that traded across the ocean, but here lies the compelling anomaly. The ruins are not confined to a single layer or depth. Researchers have identified multiple phases of construction, with older structures found further out to sea and under deeper layers of sediment. This suggests a complex history not of one sudden drowning, but of a city repeatedly battling a changing coastline. The land here is geologically active, prone to both gradual subsidence and sudden seismic events. The cultural memory preserved in the texts may not be recalling a single day of destruction, but a prolonged epoch of struggle, of walls being rebuilt further inland as the sea advanced, until a final, catastrophic event, perhaps a powerful earthquake-induced subsidence, doomed the last incarnation of the city. This pattern transforms the ancient story from mere myth into something profound, a cultural record of a people's lived experience with a sinking shore. The stone anchors found on the seabed are not just artifacts, they are anchors for the legend itself, tethering a spiritual narrative to a physical, geological reality. It invites a reflective question that echoes across other ancient cultures. Can we read the flood narratives found in texts from the Bible to the Epic of Gilgamesh not as mere moral tales, but as cryptic records of widespread coastal catastrophes that reshaped the human world? If the story of Dwarka preserves the echo of a real city's fall, It suggests our ancestors were documenting profound geological events through the language of myth and divinity. From this realm where faith and geology intertwine, our search for sunken truths leads to a place where the stones themselves seem to whisper in a language of precise mathematical code. The stones of Bimini lie in water so clear and shallow they seem to invite you to walk upon them. Just off the coast of North Bimini Island in the Bahamas, the seabed is paved with a striking formation, a long line of massive, rectangular limestone blocks arranged with startling regularity. This is the Bimini Road, or as some call it, the Bimini Wall. From the air, it looks like a sunken highway or the foundation of a colossal pier, stretching for nearly half a mile parallel to the shoreline. The blocks are enormous, some weighing several tons, and they fit together in a rough but persistent pattern of right angles and straight edges. It is a sight that immediately sparks a single, powerful question. Is this a masterpiece of geology or a message from a lost world? The debate has raged since its discovery in the 1960s, fueled by its location on the Great Bahama Bank. This vast submarine plateau was completely above sea level until approximately 6,000 years ago. This time frame is the first crucial piece of the puzzle. It means that when this formation was created, whatever its origin, it was on dry land. For proponents of a human origin, this fact is foundational. They argue the structure's form is too organized to be random. Researchers like Dr. Greg Little point to specific features, such as blocks that appear to be stacked in two distinct layers, suggesting purposeful construction. Some stones show what look like tool marks or mortise holes, and the entire alignment of the road is said to point toward significant celestial points, a hallmark of many ancient sacred sites. The comparison is often made to known ancient maritime engineering, like the breakwaters of Greek or Roman harbors, functional structures designed to withstand the sea. Geologists, however, offer a compelling and elegant natural explanation. They identify the stone as beak rock, a type of sandstone that forms rapidly in tropical tidal zones where sand and shell fragments are cemented together by calcium carbonate. The key process here is syneresis cracking. As the cement dries and shrinks, it creates stress fractures within the rock layer. These fractures naturally propagate in straight lines and often intersect at right angles, much like the cracking pattern in drying mud. Over time, the sea erodes the softer material around these fractures, leaving behind the harder, cemented blocks, which then settle into the neat, rectangular grid we see today. The two-tiered appearance, skeptics argue, could simply be two separate layers of beak rock that formed at different times, with the upper layer fracturing and settling onto the lower one. The perceived tool marks could be the result of mollusks boring into the stone or the natural pitting of erosion. This leaves us at an intriguing impasse. The Bimini Road is a perfect Rorschach test of history. Its appearance is undeniably suggestive, whispering of human intention in every straight line. Yet the natural processes that could create it are well documented and demonstrable. In the absence of definitive artifacts like pottery, tools, or carvings found in direct association with the stones, the scientific consensus leans heavily toward the geological explanation. This tension forces a deeper, more personal reflection. When we gaze upon such an ambiguous formation, how much of what we see is shaped by our own profound desire to find traces of lost civilizations, to connect ourselves to a grander, forgotten narrative? The stones themselves are silent, allowing both the dreamer and the skeptic to find confirmation. This challenge of perception, of separating human hope from geological fact, becomes even more stark when we leave the sun-drenched tropics for a place where the water is dark, cold, and holds a different kind of secret. The clear, sunlit shallows of Bimini offer one kind of puzzle, a question of form and intention. But in the cold, dark waters of the Baltic Sea, a discovery was made that presents a mystery of pure, unsettling geometry. In 2011, a Swedish team named Ocean X was using sonar to search for historic shipwrecks when their screens displayed something that defied all expectation. Resting on the flat, muddy seabed at a depth of 90 meters was a perfect circular object. It was not a wreck, it was a structure, or at least something that looked exactly like one. The sonar image was so bizarre, so artificial in appearance, that the team immediately nicknamed it for its resemblance to a famous spacecraft, the Millennium Falcon from Star Wars. The Baltic Sea Anomaly was born, and with it, a debate that has raged for over a decade. The primary image shows a nearly perfect circle, roughly 60 meters in diameter. A raised ridge runs around its circumference, and at its center, a smaller, circular formation sits like a command tower. Most striking of all, leading away from the object is a long, straight track, almost like a skid mark or a runway, stretching for nearly 300 meters across the seafloor. Subsequent dives by the team reported even stranger details. They claimed their electrical equipment would mysteriously fail when directly above the object. They brought up rock samples that, when analyzed, were said to contain metals like limonite and goethite, materials not typical for that part of the Baltic. Some even spoke of a staircase-like formation on the side of the object. The immediate and obvious question is, what is it? The theories span the spectrum from the mundane to the extraordinary. On one end, geologists and maritime archaeologists point to a far more likely explanation. The Baltic Sea region was heavily sculpted by glaciers during the last ice age. These immense sheets of ice carried and deposited vast amounts of rock and sediment. As they retreated, they left behind erratic boulders, drumlins, and other formations. Many experts argue the anomaly is simply a rare but natural glacial deposit, perhaps a large outcrop of basalt that fractured in unusual ways as it was dragged across the bedrock. The straight track could be the groove carved by the glacier itself. They note that the human mind is exceptionally good at seeing familiar shapes, especially right angles and circles, in random patterns, a phenomenon called pareidolia. Yet the object's stark, geometric perfection continues to fuel speculation. Could it be a lost, ancient monument from a time when this area was dry land, a Stone Age structure now submerged, or, as some have wildly proposed, something not of this earth? The mystery deepened when other sonar surveys in the region revealed additional oddities, including long, straight lines and formations that some dubbed the Nazca lines of the Baltic. This context is important. It suggests the seafloor here may be a gallery of unusual glacial art, not a parking lot for alien spacecraft. The subsequent lack of clear, peer-reviewed scientific analysis from the original team has left the anomaly in a frustrating limbo. Without definitive samples or a full, transparent survey, it remains a captivating sonar ghost, so we are forced to confront a fundamental line of inquiry. When does a geological oddity stop being just a curious rock and start whispering the possibility of a human, or even unearthly, hand? The Baltic Sea Anomaly sits precisely on that razor's edge. It challenges us to question our own desire for discovery against the backdrop of a planet capable of creating shapes so perfect they feel designed. This single, enigmatic circle points toward a broader truth, that our ocean floors are not barren wastelands, but archives of the Earth's most dramatic and creative processes. To move from one mysterious object to an entire hidden civilization, we must journey to a place where the water is not cold and dark, but warm, shallow, and astonishingly clear. The Baltic Sea Anomaly is a solitary puzzle on a vast seabed, but what if we shifted our gaze to a scale so immense it redefines the very idea of a lost world? Beneath the turquoise waters of Southeast Asia lies not just a sunken city, but an entire drowned continent. This is Sundaland, a forgotten geographic reality that was once the stage for some of humanity's earliest journeys. During the last ice age, when sea levels were over 400 feet lower, a vast continental shelf was exposed. This connected what are now the islands of Java, Sumatra, and Borneo to the Asian mainland, creating a continuous landmass nearly the size of Europe. It was not a barren plain, but a rich, varied landscape of river valleys, forests, and coastal estuaries, a paradise for early human populations. The conventional story is that this land was slowly claimed by the rising post-glacial seas over thousands of years. Yet, emerging research suggests its end may have been far more dramatic, an event seared into the collective memory of countless cultures. The work of researchers like Stephen Oppenheimer weaves together disparate threads of evidence into a compelling tapestry. He points to a convergence of geology, genetics, and folklore. Population genetic studies show distinct patterns of human migration radiating outward from this region around the time of its inundation. Simultaneously, a flood of deluge myths saturates the oral traditions across Southeast Asia and the Pacific, from the Philippines to Malaysia, stories that speak not of a gentle rising tide, but of a wall of water, a catastrophic event that forced survivors to flee to the hills and set out in boats for new land. The geological evidence on the seafloor provides a stunning physical backdrop for these stories. Bathymetric maps of the Sunda Shelf reveal the ghostly outlines of an ancient world. We can clearly see the sprawling networks of drowned river valleys, including a massive system that once flowed through what is now the Malacca Strait. These are not subtle features, they are the unmistakable signatures of a landscape carved by water and wind over millennia, now resting silently under shallow seas. This brings us to a crucial geological nuance. While sea levels did rise steadily, that process was likely punctuated by sudden, terrifying pulses. One proposed mechanism is the catastrophic collapse of glacial ice dams holding back vast lakes in North America and Eurasia. These glacial lake outburst floods would have unleashed unimaginable volumes of freshwater into the world's oceans, causing rapid, destabilizing sea level rises in a matter of years or even months. For the communities living on the low-lying coastal plains and river deltas of Sundaland, such an event would not have been a gradual retreat. It would have been an apocalyptic rush of water, swallowing their hunting grounds, villages, and sacred sites in a single generation. A powerful parallel exists far to the west in the North Sea. There, the lost landmass known as Doggerland, which once connected Britain to mainland Europe, met a similar fate, its final destruction likely sealed by a colossal underwater landslide off Norway that triggered a devastating tsunami. The story of Sundaland forces us to ask a profound question that echoes across these shallow, sun-drenched seas. How many archaeological treasures, how many settlements marking the dawn of urban development, lie buried under centuries of sediment, lost not to time but to a sudden, rising wrath of water? This concept of a spiritually significant landmass consumed by the ocean finds its most poignant and enduring symbol in a place that is not a continent, but an island and a legend. The legend of the 7 pagodas has echoed along the Coromandel coast of India for more than 1,000 years. At the ancient port city of Mahabalipuram, one magnificent shore temple has always stood in plain view, a masterpiece of Pallava dynasty stone carving. But local folklore insisted it was not alone, that it was the lone survivor of 7 such glorious temples, its 6 siblings claimed long ago by the sea. For centuries, this was considered a poetic metaphor, a story to explain the power of the ocean. Then, in 2004, the ocean itself decided to reveal the truth. The devastating Indian Ocean tsunami that year acted like a giant, terrible hand, scouring away vast quantities of sand from the seabed just off Mahabalipuram's coast. When the waters cleared, sonar and divers from India's National Institute of Oceanography found not one lost temple, but the staggering remains of a massive submerged complex. Stretching over a mile along the seafloor, the surveys revealed fallen walls, scattered stone blocks, and the distinct foundations of man-made structures, including steps and plinths that spoke of grand entrances and pavilions. The sheer scale of the ruins confirmed the legend was not a myth but a memory. The anomaly here is not the fact of submergence but its cause and speed. While gradual sea level rise played a background role, the archaeology tells a story of sudden violence. The ruins are not neatly laid out like a city slowly abandoned. They are in disarray with large structural elements toppled and scattered, a signature of catastrophic force. Geological studies of the region point to a likely culprit, a massive seismic event around 1,000 years ago. This area sits near a complex tectonic boundary, and historical records from that period note great earthquakes that reshaped the coastline. The evidence suggests that during such an event, a substantial section of the coast at Mahabalipuram underwent rapid land subsidence. The ground literally dropped perhaps several meters in a matter of minutes, plunging the active temple complex into the advancing surf. A useful parallel can be found in the ancient Egyptian city of Heracleion, where a combination of soil liquefaction and subsidence sent its grand harbors sliding into the Mediterranean. At Mahabalipuram, the temples did not drown from the sea patiently rising. They were swallowed when the earth abruptly gave way beneath them. This transforms the local legend from a fanciful tale into a precise historical guide. It preserved the knowledge of a profound cultural loss across generations, waiting for the moment when technology and circumstance could confirm it. This invites a powerful reflection that reaches far beyond this Indian shore. Around the world, how many other so-called myths are not stories at all, but oral archives, carefully maintained records of real geological disasters that reshaped the human world? When a community speaks of gods or giants flooding the land, might they be encoding the traumatic memory of a tsunami or a sinking coast? The discovery at Mahabalipuram suggests we should listen more closely to the oldest stories. From this temple complex where legend became fact, our search leads to a far more isolated enigma, a solitary and perfect shape resting in the deep Pacific, waiting to be understood. A world away from the sunken temples of India in the remote western Pacific, a city of stone rises from a coral reef. This is Madol, a labyrinth of 92 artificial islets built not on solid ground, but upon the living foundations of a shallow lagoon. Its name fittingly means the spaces between, referring to the network of canals that weave through the ruins. While much of this Venice of the Pacific stands defiantly above the waterline, a critical part of its mystery lies in what has slipped beneath it. Entire seawalls, foundational platforms, and sections of canal are now permanently submerged, suggesting a relationship with the ocean far more complex than a simple, global rise in sea level. The first and most immediate wonder is the construction itself. The city is built from colossal basalt logs, some weighing up to 50 tons. These prismatic columns were quarried from the opposite side of Pohnpei Island, transported across miles of jungle and open water, and then meticulously stacked like log cabins to form towering walls and platforms. How a society without metal tools or pulleys achieved this remains one of archaeology's great puzzles, a feat so immense that local oral history attributes it to magic, with legends telling of a sorcerer who flew the stones into place. Archaeologist Dr. Rufino Mauricio, who has studied the site for decades, emphasizes the staggering logistics. The builders moved an estimated 750,000 metric tons of stone, all to create a ceremonial and political capital for the powerful Sordelor dynasty atop an unstable coral foundation. This choice of location is the heart of the environmental anomaly. Madol was built directly on the fringing reef, a dynamic and sensitive environment. While global sea levels have risen since its construction around 1,000 years ago, the specific pattern of flooding at Nan Madol does not neatly match that broad trend. Key structural elements are submerged at inconsistent depths, and the inundation seems localized to the complex itself. This points strongly toward local geological change, a phenomenon experts call relative sea level rise, where the land moves independently of the ocean. Given Pohnpei's volcanic origin, the island itself may be undergoing subtle subsidence or tectonic tilting. The immense weight of the city's stone structures, concentrated on the fragile coral base, could have accelerated this process, causing the entire built area to slowly sink or settle unevenly into the soft substrate. You can see this history written in the stones today. Divers and researchers have mapped submerged walls that extend far deeper than the functional canals would require, and foundational platforms now lie completely underwater, indicating the ground level has shifted since their construction. This pattern finds echoes across the Pacific, from the coastal erosion threatening Easter Island's iconic Moai platforms to the sinking atolls of Kiribati. At Nan Madol, however, the story is uniquely intertwined with human ambition. It presents a profound question about legacy and environment. Could the Sodalor dynasty's greatest achievement, their attempt to literally build a kingdom from the sea, have set in motion the very geological processes that began to reclaim it? This idea of a civilization's footprint altering its own foundation leads us from a remote island capital to a sunken city whose name alone evokes the ultimate lost civilization. The legend of Atlantis has haunted our imagination for 2,000 years. Plato's story of a mighty island empire that vanished beneath the sea in a single day and night of misfortune stands as the ultimate lost civilization myth. And when searching for a real-world inspiration, one location rises from the Mediterranean with breathtaking force: the island of Santorini. Today, its dramatic crescent shape and sheer cliffs are the stunning scar of a catastrophe. Around the year 1600 BC, the volcano at the heart of this island, then known as Thera, unleashed one of the most powerful eruptions in human history. The event was apocalyptic. The central cone of the mountain collapsed in on itself, creating the vast, deep caldera that now holds the sea. This was not a slow sinking, but a sudden, violent implosion. The land did not drown from rising water. It was replaced by water as the ocean rushed into the newly formed abyss. The geological evidence is stark and clear. Layers of ash and pumice, some dozens of feet thick, blanket the island and the surrounding seabed. Volcanologists can reconstruct the sequence, a series of colossal explosions that emptied the magma chamber, followed by the catastrophic structural failure of the mountain's summit. The resulting tsunamis, waves estimated to be over 100 feet high, would have radiated across the Aegean Sea, devastating the coast of Crete and crippling the sophisticated Minoan civilization that thrived there. This is a textbook case of a cataclysmic, non-sea level drowning. The submergence of Thera's central landmass was caused by a volcanic caldera collapse, a specific and dramatic geological process. For this reason, while Santorini is a compelling candidate for inspiring elements of the Atlantis legend, it does not qualify as one of our truly anomalous sites, those that cannot be explained by known large-scale events. Its cause is not a mystery, it is a well-understood, albeit terrifying, chapter in Earth's history. The archaeological record on Santorini itself adds a profound human dimension. At the site of Akrotiri, excavators uncovered not a sunken city, but a buried one. This Minoan town was preserved in volcanic ash, a Bronze Age Pompeii, with multi-story buildings, vibrant frescoes, and everyday objects frozen in time. The people had evidently been warned, perhaps by earlier tremors, and evacuated, for no remains have been found in the ash. This is crucial. Akrotiri was entombed, not flooded. The link to Atlantis comes from the distortion of memory over centuries. Imagine the stories that survivors carried with them, tales of a mighty island shaken by earthquakes, covered in darkness, and then consumed by the sea as its center vanished. Over generations, as these accounts traveled, the details of ash and volcanic collapse could have transformed into a narrative of a circular island city, sinking beneath the waves as punishment from the gods. Plato, writing over 1,000 years later, could have woven these fragmented, mythologized memories into his philosophical allegory. The reflective power of Thera is immense. If a historical event of this scale and specificity can be so profoundly reshaped by time and retelling, what does that suggest about the countless other flood myths found in every corner of the globe? They may not all be memories of the same event, but they likely encode real, traumatic experiences of coastal destruction, whether by tsunami, land subsidence, or rapid sea level rise. Thera teaches us to listen to the geology first. It provides a clear distinction, a benchmark for a known type of catastrophe. This distinction becomes our most vital tool as we now turn to a site where no such clear cause exists, a place that defies even the logic of volcanoes and earthquakes, resting in a lake where nothing so grand should ever have been built. The clear volcanic history of Thera shows us what a known catastrophe looks like, but in the murky waters of India's Gulf of Cambay, a discovery was announced that offered no such clarity, only a storm of controversy that still rages today. In 2001, India's National Institute of Ocean Technology made a startling claim. Their sonar surveys of the seabed, at depths between 30 and 40 meters, had revealed what appeared to be vast geometric formations, including what looked like stepped structures spread across a 9-kilometer area. This was not all. Dredging operations brought up material that seemed to confirm a human presence, including pieces of pottery, worked wood, and even what were described as fragmentary human remains. The immediate implication was staggering. If these were the ruins of a city, and if the wood samples recovered were part of its construction, then carbon dating that placed them at around 9,500 years old would rewrite history. This would push the origins of complex urban civilization in the Indian subcontinent back thousands of years before the great Indus Valley cities of Harappa and Mohenjo-Daro. The site would have existed in a dry river valley during the last ice age, only to be drowned as sea levels rose and the basin filled. The anomaly here is not just depth but profound antiquity. The controversy erupted almost instantly, creating a deep divide within the archaeological community. The NIOT team and their supporters pointed to the compelling sonar images, the physical artifacts, and the radiocarbon dates as a coherent package of evidence. They argued the geometric patterns on the seabed, with their right angles and linear features, were inconsistent with natural topography. The recovered materials, they suggested, could not have been carried so far out to sea by river currents alone, implying they were in situ, part of a settlement that had sunk. Critics, however, raised serious and methodical objections. They questioned whether the sonar images showed anything more than natural sandstone formations, which can fracture into remarkably regular blocks. They argued the artifacts recovered by dredging, a notoriously imprecise method, could have come from any number of times and places, swept into the Gulf by ancient rivers and deposited over millennia. The carbon-dated wood, they noted, only tells when the tree was alive, not when it was used as a building material. It could have been ancient driftwood used by a much later culture. The mention of human remains added a layer of sensitivity, with experts cautioning that such finds require extremely careful contextual analysis to determine their origin and significance, analysis that the dredging method simply could not provide. This case stands as a powerful cautionary tale in underwater exploration. It highlights the tension between the thrilling announcement of a potential paradigm-shifting discovery and the slow, meticulous, often unglamorous process of scientific verification. For a claim this extraordinary, the evidence must be ironclad. Subsequent research missions have failed to conclusively settle the debate. Without systematic excavation, where artifacts are found in clear layers and in association with architectural features, the Gulf of Cambay remains an enigma suspended between possibility and skepticism. This forces a difficult but essential question for all of us fascinated by lost worlds. How do we responsibly balance our excitement for a revolutionary find with the disciplined patience required by science? The controversy in Cambay's cloudy waters shows that sometimes the most challenging ruins to explain are not those hidden by the sea, but those obscured by the fog of uncertainty. To find a mystery with a clearer physical paradox, we must travel to a place where the depth itself is the undeniable and baffling evidence. The controversy of Cambay lies in what we cannot yet see, but in the clear waters of the Mediterranean, a single stone tells a story we can no longer ignore. Resting 40 meters beneath the surface of the Strait of Sicily is a 12-meter-long slab of limestone. It is not a random boulder. This object, discovered in 2015 on a submerged plateau called the Pantelleria Vecchia Bank, is a meticulously crafted monolith. It lies broken cleanly in two, and along its length are three perfectly regular drilled holes. This is not a natural formation. It is a piece of architecture resting on a seafloor that was not a seafloor when it was placed there. This site was a thriving island until approximately 9,500 years ago, when rising post-glacial seas finally claimed it. The monolith's presence is a direct challenge to our understanding of a shadowy period known as the Mesolithic era. Mainstream history suggests that Mediterranean seafaring at this time was primitive, limited to small coastal hops. Yet here is a stone that tells a different tale. A team from Italy's National Institute of Oceanography and Experimental Geophysics studied the site in detail. They concluded the monolith was clearly cut, transported, and erected by human hands. The three holes are the most telling evidence, one drilled completely through the stone at one end, the other two on its sides, likely used for ropes or leverage in positioning. This was not a simple marker. Its size and design suggest it was part of a larger structure, perhaps a primitive lighthouse, a navigational aid, or a ceremonial site for a community living on this now vanished island. To understand the scale of this achievement, we must picture the era. 9,500 years ago, while hunter-gatherers roamed Europe, someone on this island in the strait possessed the knowledge to quarry a multi-ton limestone block. They had the tools, likely stone and wood, to shape it and drill through it with precision. They had the social organization to coordinate moving it and standing it upright. This technological leap is staggering. Consider a rough contemporary, the earliest phases of Stonehenge in Britain, where the first earthworks began around 5,000 years ago. The Sicilian monolith predates that by over 4 millennia. It forces a complete re-evaluation of what Mesolithic societies were capable of, not just in survival, but in communal engineering and maritime confidence. The geological history of the region adds crucial context. The Adriatic and Ionian basins were dramatically different landscapes during the last ice age. Vast plains now underwater were exposed, creating archipelagos and connecting landmasses. The Pantelleria Vecchia Bank was a high point in this ancient world, a strategic and likely resource-rich island in what was then a narrow marine channel. The people who lived there were not isolated. They were positioned at a crossroads, and their monument suggests a culture with a need to communicate, to mark territory, or to venerate something. The reflective power of this single stone is immense. It asks us to envision not just a few scattered families, but a society with purpose, memory, and the skill to alter their landscape in a permanent way. What ceremonies took place around this stone? What did they watch for on the horizon? Their entire world, their home, now lies silent under 40 meters of Mediterranean blue, remembered only by this one fractured sentinel. From this solitary, profound artifact, our search expands to a scale that defies the very notion of coincidence, to a pattern etched across the seabed that looks unmistakably like the streets of a modern city. The monolith in Sicily is a solitary piece of undeniable human craft, but what happens when our eyes, so eager to find lost cities, play tricks on us? In the stunningly clear, turquoise waters off the coast of Zakynthos, Greece, a discovery seemed to offer the perfect answer. Scattered across the sandy floor of Alicona's Bay lay what looked like the remains of a classical settlement. There were circles of stone that resembled the foundations of a colonnade. There were low walls that appeared to form rooms and courtyards. Most compelling of all were the flat, paved surfaces that looked like ancient floors. It was a breathtaking sight, and initial reports buzzed with the excitement of a potential lost city, another Pavlopetri waiting to tell its story. The visual evidence felt overwhelming, a sunken blueprint of a forgotten community. Then science stepped in to tell a different, and in its own way, more remarkable story. A team from the University of Athens conducted a meticulous analysis, and their conclusion was definitive. This was not a city, it was a masterpiece of geology. The so-called ruins were the product of a rare and fascinating natural process linked to methane seepage. Beneath the seafloor, microorganisms feed on methane rising from deeper deposits. As they metabolize the gas, they change the chemistry of the surrounding sediment, causing minerals, primarily dolomite, to precipitate and cement the sand and shells into solid, concrete-like formations. The process is not random. It often creates self-organizing shapes, including the perfect circles and linear ridges that so convincingly mimicked man-made foundations. The researchers used a suite of diagnostic tools to prove their case. Under microscopes, the material showed no tool marks, only the granular texture of cemented sediment. Isotope analysis of the carbon within the stone directly traced its origin to microbial methane consumption, a signature never found in quarried building stone. The lesson of Zakynthos is not one of disappointment, but of critical thinking. It is a powerful case study in pareidolia, our brain's hardwired instinct to find familiar patterns in random shapes. We see a face in the clouds, a pyramid on Mars, and in this bay, the ghost of a city. This site teaches us the rigorous methodology required to separate human history from Earth's artistry. It asks us to apply a more analytical lens. How many other submerged anomalies, celebrated as mysteries, might have similarly natural, if extraordinary, explanations? This disciplined perspective is essential as we now confront a site where the human artifacts are undeniable, but their location defies every logical explanation for how they got there. High in the thin air of the Andes, Lake Titicaca holds a mystery that turns our understanding of sunken ruins upside down. Here, the anomaly is not found in the crushing depths of an ocean, but in the vast, sky-high waters of the world's highest navigable lake. At 3,812 meters above sea level, this is the last place you would expect to find a submerged city. Yet, beneath its famously serene surface lies compelling evidence of a lost chapter, one flooded not by rising oceans, but by a dramatic and local transformation of the land itself. The discoveries here began with local fishermen who spoke of ancient structures visible in the clear water. These stories prompted a formal investigation, leading underwater archaeologist Christophe Dallaire and his team to map sections of the lakebed near the island of the Sun. What they found was not a random scattering of stones, but the organized remains of a major ceremonial complex. Their sonar and dives revealed a 200-meter-long wall, a submerged terrace system for agriculture, and the foundations of a temple measuring 50 by 20 meters, its scale speaking of a significant and centralized society. But the most telling finds were the artifacts recovered from the site. Divers brought up finely crafted gold foils, ornate ceramic incense burners, and the bones of sacrificial llamas, all in a remarkable state of preservation. These were not the belongings of a simple lakeside village. They were the ritual offerings of a sophisticated culture, deliberately placed in what was then a sacred building on dry land. This is the heart of the mystery at Titicaca. The lake's water level is not governed by distant melting ice caps. It is a closed basin, its volume dictated entirely by the delicate balance of rainfall and evaporation on the high altiplano. Geological and sediment core studies reveal that around 1,000 to 1,500 years ago, during the peak of the Tiwanaku Empire, the lake was significantly lower, perhaps by as much as 10 meters. The temple complex now underwater would have stood proudly on a peninsula or a connected island, a center of spiritual and political power. Then the regional climate shifted. A period of increased rainfall, possibly linked to broader patterns like the South American monsoon, caused the lake to swell, slowly and inexorably flooding the Tiwanaku's sacred shoreline structures over generations. This process was likely compounded by the region's tectonic activity, as the altiplano itself is a slowly rising plateau which can tilt basins and alter drainage patterns. This story finds a quiet parallel far away in places like the submerged forests of England, where freshwater lakes or rising peat bogs have claimed Neolithic landscapes, preserving them in a different kind of time capsule. The case of Lake Titicaca forces a profound shift in perspective. We are conditioned to associate sunken ruins with saltwater and global cataclysms. But here, a civilization's legacy was reshaped by the sky, by the intimate climate of its own mountain home. So we must ask, if a changing climate could drown the temples of a mighty empire high in the Andes, how many other inland civilizations have had their histories rewritten not by the sea, but by the silent, rising waters of their own rivers and lakes? This question of an empire's sunken frontier leads us from the high Andes to the very edge of another legendary domain, where the ruins are not of temples but of a sprawling imperial port. Port Royal did not drown from a rising tide. It was swallowed whole by the earth. On the 7th of June, 1692, this notorious pirate capital, branded the wickedest city on earth, was in the midst of a sweltering morning. Within minutes, a catastrophic earthquake struck, and the unthinkable happened. A large portion of the city simply slid into the harbor, submerged as if a giant hand had pulled it under. This event provides a perfect, documented case study for understanding a type of submersion that has nothing to do with global sea levels. It is a masterclass in rapid, seismic drowning. The city was built on a precarious foundation, a sand spit that extended into Kingston Harbor. When the intense shaking of the earthquake hit, a phenomenon called liquefaction occurred. The water-saturated sand lost its solid structure, behaving like a liquid. Buildings lost their footing, and entire city blocks flowed into the sea, trapping their contents in a moment frozen in time. This makes Port Royal one of the world's most extraordinary underwater time capsules. Archaeological excavations led by researchers like Dr. Donnie Hamilton have revealed a 17th-century world preserved with stunning clarity. Because the subsidence was so sudden, there was no time for looting or salvage. Archaeologists have found buildings still standing, with walls intact. They have recovered everyday artifacts exactly where they were left, from pewter plates and wine bottles to personal items like pipes and shoes. The site offers a poignant, undisturbed snapshot of colonial life and even of its final moments. The geological setting explains why this happened here. Port Royal sits directly on the boundary of the Caribbean and Gonave tectonic plates, a region of immense seismic stress. The 1692 earthquake is estimated to have been a magnitude 7.5, a force powerful enough to trigger massive liquefaction in the loose, waterlogged sediments of the spit. Geologists study this event to understand how ground failure can amplify destruction. The reflective power of Port Royal is immense. If a well-documented modern city can vanish into the sea in minutes through local land subsidence, what does that imply for countless prehistoric settlements built on similar unstable ground? How many of our so-called drowned ancient cities met not a gradual fate, but a sudden Port Royal-style doom, their stories cut short by the ground turning to liquid beneath them? This example of seismic catastrophe leads us to a site of a different, more chilling nature, where the earth did not liquefy, but simply opened a deep and silent mouth. The ground can swallow a city in minutes, but it can also lower a forest with a single, terrible groan. On the misty Pacific coast of Washington state, the tides at Copolis Beach reveal a haunting sight, the stumps of an ancient cedar forest, still standing upright where they grew, now surrounded by saltwater and sand. These are not driftwood logs, they are the tombstones of a living ecosystem, killed and preserved by a catastrophe so precise we can date it to the very day. This is the sunken forest of the Olympic Peninsula, and its story rewrites our understanding of how coastlines can die. For decades, these ghostly stumps were a local curiosity, explained away as a forest slowly claimed by rising seas. But to the trained eye of a geologist like Dr. Brian Atwater, the scene told a different, more violent tale. The key lay in the layers beneath his feet. He observed a clear sandwich of history in the soil. First, there was a layer of old forest soil with roots and marsh plants, showing this was once stable, dry land. Sitting directly on top of that soil was a thick deposit of clean, white sand, the kind found offshore, not inland, and on top of that sand was the modern beach. This stratigraphy was a geological crime scene. The clean sand was a tsunami deposit, a wave that had surged inland, scouring the seafloor and dumping its load over the drowned forest. But for a tsunami to bury the trees, the land had to sink first, lowering the forest into the intertidal zone where the waves could reach it. This pointed to a specific, terrifying mechanism, seismic subsidence. During a mega-thrust earthquake at the nearby Cascadia subduction zone, where the oceanic plate dives beneath the continent, the overriding North American plate can snap upward, then slump downward permanently. In one shuddering event, hundreds of miles of coastline can drop by several feet, instantly turning forests into wetlands and inviting the ocean in. The detective work did not stop there. By studying the tree rings of the drowned cedars, scientists made an astonishing connection across the Pacific. The outermost ring on every stump showed the trees died in the growing season of 1699. By analyzing the pattern of the rings, they could pinpoint the season of death, the winter. Then they consulted historical records in Japan. Documents from villages along the Japanese coast described a mysterious tsunami with no local earthquake, an orphan wave that struck on January 27, 1700. The timing aligned perfectly, accounting for the tsunami's travel time across the ocean. The earthquake that sank the Washington forest had occurred on the evening of January 26, 1700. This precise dating is the profound anomaly. It is not a story of millennia but of minutes. A 9.0 magnitude quake lowered the land, and within perhaps 30 minutes, the tsunami it generated arrived to finish the job, burying the roots in salt and sand. This event is not a relic of a distant past. It is a recurring feature of the Cascadia zone, which ruptures roughly every 500 years. The reflective power of this quiet beach is immense. If a single stand of cedars can preserve the exact date of a continent-scale cataclysm, how many other coastal ruins, currently attributed to slow sea level rise, are actually the unmarked graves of ancient seismic events? How many vanished settlements lie along shorelines we have not yet learned to read with such forensic clarity? This understanding of land that can suddenly fall away leads us from a drowned forest to a different kind of swallowed treasure, where intricate stonework rests not in the ocean, but in the deep, still waters of a mountain lake. High in the Colombian Andes, Lake Tota holds a legend as deep and cold as its waters. For centuries, the Muisca people have passed down a story of a great temple dedicated to Soe, the sun god, that once stood proudly on the shore. According to their oral histories, the temple was flooded as a divine punishment, its sacred stones now resting silently beneath the lake's surface. This is not just a myth, but a specific cultural memory that has persisted through generations, pointing to a precise location and a specific loss. In recent decades, this legend has collided with modern technology, creating one of South America's most compelling underwater mysteries. Sporadic sonar surveys of the lakebed have occasionally returned puzzling images, showing what appear to be large geometric shapes. Reports describe right angles and flat surfaces in formations that seem inconsistent with the natural, sloping contours of a volcanic lake floor. These readings suggest the possibility of a stepped platform or a ceremonial center, a structure that would align perfectly with the Muisca legend of a sunken temple. The anomaly here is not just the potential structure, but the powerful convergence of indigenous oral tradition and ambiguous technological data. The Muisca were an advanced culture, famed for their goldworking and their elaborate rituals, including the ceremony that inspired the legend of El Dorado. The idea that they built significant temples is not in question. The mystery is whether one of them met a fate beyond simple erosion. Investigating this claim, however, presents immense challenges. Lake Tota is deep, cold, and sits at an altitude of over 3,000 meters. The water is dark with limited visibility, and the lake's sheer size makes systematic scanning a costly and complex endeavor. A handful of diving expeditions have ventured down, but they have returned with more questions than answers, speaking of vast, shadowy shapes on the bottom that defy easy classification. The scientific community remains rightly cautious. Geologists point out that underwater landslides in a steep-sided basin can create remarkably regular, terraced shapes as sediment settles in layers. What a sonar might interpret as a flat, man-made platform could be a natural bench of hardened volcanic clay. Without a detailed archaeological survey that can distinguish tool marks from erosion or retrieve cultural artifacts from the sediment, the pyramid of Lake Tota remains in the realm of compelling possibility. This case forces a broader, more reflective question about how we value different kinds of evidence. When does a persistent legend, held sacred by a culture for centuries, warrant the major investment of a full-scale scientific investigation? It is a question of resources, but also of respect for treating an oral history as a valid hypothesis worthy of testing. The search for such drowned sacred sites is not unique to Colombia. Similar stories echo around other Andean lakes, where changing water levels have often reshaped the relationship between people and their landscape. For now, the temple to Sai remains a whispered promise in the sonar static, a testament to the enduring power of story and the patient, dark water that keeps its secrets. From this high-altitude enigma, our search for clarity descends to a place where the water is brilliantly transparent and the ruins are undeniable, waiting off the coast of a land steeped in ancient memory. The submerged village of Atlat-Yam rests in a silent, blue world off the coast of Israel, a perfectly preserved window into a time 9,000 years ago. While its final drowning by the Mediterranean aligns with known sea level rise, the story of its abandonment is a sudden, shocking mystery. This is not a village that faded away, it is a community that fled, leaving its life behind in a single, terrible moment. The evidence lies in the seabed itself. Archaeologists led by Dr. Ehud Galilee discovered a thriving Neolithic settlement, complete with stone houses, hearths, and courtyards, all eerily intact. They found a ceremonial stone circle, its monolith still standing, and a deep, stone-lined well at its center, a vital source of fresh water. But covering the entire site is a thick, uniform layer of sand, a clear geological signature of a powerful, single event. This layer sealed the village like a time capsule, protecting it from the eroding waves that would follow. The most poignant clues, however, came from the human remains found within the houses. Analysis of these individuals revealed the earliest known cases of tuberculosis in the world. This suggests a community under severe stress, their health compromised, living in a place that was becoming increasingly perilous. Dr. Galilee's research points to a catastrophic trigger, a tsunami. The theory suggests that a massive volcanic eruption, possibly from a precursor to the Thera volcano far to the north, generated a towering wave that struck the Carmel coast. The tsunami would have inundated the village with seawater, destroying its freshwater well with salt and depositing that defining blanket of sand. The combination of a ruined water supply, disease, and the trauma of the disaster would have given the inhabitants no choice but to gather what they could and abandon their home forever. The sea then slowly rose over centuries to claim what the wave had already condemned. A useful parallel can be drawn to Pompeii, though the agent of destruction was different. Both sites capture a single day in the life of a community, frozen by a rapid burial that allowed for extraordinary preservation. Atlet Yam forces us to ask a haunting, reflective question. If this one village's end was so abrupt, how many other early coastal settlements, the very cradles of human civilization, met their fate not with the slow creep of water, but with the sudden, devastating bang of a distant catastrophe? This theme of tsunamis reshaping human geography leads us to a land bridge that did not just vanish, but was violently shattered. Satellite images from space reveal a ghostly pathway stretching across the sea. Between the southern tip of India and the northwestern coast of Sri Lanka, a chain of shoals and sandbanks traces a line so straight, so purposeful, it feels like a bridge interrupted. This is Adam's Bridge, also known as Rama's Bridge, and it is a place where geology and epic poetry collide in the shallow waters of the Palk Strait. For millions in the Indian subcontinent, this is not merely a natural formation. It is the setting of one of humanity's oldest and most revered stories, the Ramayana, which tells of a divine prince, Rama, and his army of Vanaras, or forest beings, building a massive causeway of stones across the ocean to rescue his beloved Sita from the demon king Ravana in Lanka. The visible, submerged chain seems to map the legend onto the landscape, creating a profound and enduring question. Is this a miraculous coincidence of nature, or does the myth preserve a distant memory of a real, walkable connection? The anomaly lies in the tension between these two powerful narratives, one written in scripture, the other written in sand and stone. The geological explanation for the bridge is clear, elegant, and well supported by science. Geologists point to a process called longshore drift. For millennia, currents flowing along the coast have carried vast quantities of sediment from the rivers of India. When these currents meet the calmer waters and existing limestone reefs of the strait, they deposit their load, building up sandbanks over time. Storms and tidal action then shape these accumulations, sometimes breaching them, sometimes rebuilding them. Bathymetric surveys show the bridge is not a solid wall, but a discontinuous series of shoals, with water depths ranging from just a meter to over 10 meters in the gaps. Core samples taken from the sandbanks reveal predictable layers of marine sediment, with no evidence of arranged stonework or artificial fill that would indicate a massive engineering project. From a purely physical standpoint, Adam's Bridge is a classic example of a tombolo, a natural spit of land formed by deposition. Experts note that such features are dynamic, changing with each major storm, and that around 5,000 to 7,000 years ago, when global sea levels were several meters lower, this chain would have been far more exposed, potentially creating a series of islands or even a complete, if rugged, land connection that could be traversed with effort. This is where the cultural narrative meets a plausible historical reality. The Ramayana is an ancient epic, but its origins lie in a period when this region's geography was different. If the chain of shoals was more pronounced or even intermittently walkable during the era the stories were being composed, it would have been a notable feature of the world. The myth of a built bridge could then be a poetic interpretation of a natural wonder or a way to explain its unusual form. This process is not unique. Consider the folk memories of Doggerland, the lost land between Britain and Europe, where stories of sunken bells and drowned cities persisted for centuries before science confirmed the submerged landscape. The story of Rama's Bridge serves a similar cultural function, encoding a geographical truth within a framework of divine heroism and cosmic struggle. It transforms a sandbar into a sacred landmark. However, this site exists in a realm beyond pure geology or archaeology. It has become a focal point of intense national and religious sentiment. In modern times, the feature has been at the center of political debates about shipping canal projects, with arguments passionately framed around both economic necessity and the protection of a sacred heritage. This controversy highlights a powerful truth. When a natural feature becomes so deeply embedded in a culture's identity and spiritual history, its story takes on a life of its own, becoming a historical force that shapes politics, inspires devotion, and defines a landscape far beyond its physical properties. The reflective question this site leaves us with is profound. At what point does the story we tell about a place become as real and as powerful as the stones and sand that form it? The bridge may be a work of nature, but its meaning is a testament to the enduring human need to find our deepest stories written upon the earth. From this symbolic crossing, we journey to a site where the very substance of the ruins defies explanation, built from a material that should not exist where it was found. The cold, dark waters of the Gulf of Maine hold a different kind of mystery, one built not from temples but from countless stones. Here, sonar has painted a startling picture of the seafloor, revealing not random rubble but hundreds of distinct stone cairns arranged in organized rows and clusters at depths up to 60 meters. These are not the massive, carved blocks of a sunken city, but deliberate piles, some reaching several meters high, stretching across the submerged landscape like a silent, drowned garden. The immediate question is one of origin, a classic debate between the hand of nature and the hand of humanity. On one side, geologists point to the region's glacial past. The Gulf of Maine was scoured and shaped by immense ice sheets, which, as they retreated, left behind vast fields of rocky debris known as moraines. Could these cairns simply be the natural tumble of stones deposited by melting ice? The patterns, however, whisper against a purely natural explanation. Researchers from the University of Connecticut and other institutions note that many of the cairns appear in linear formations and deliberate groupings that seem inconsistent with chaotic glacial dumping. Their shapes are often conical or mound-like, and their placement suggests a purpose, a pattern repeated by human cultures across time and continents. Archaeologists leaning toward a human origin point to the sea level history of the region. Around 4,000 years ago, during the Archaic period, sea levels in the Gulf were significantly lower. What is now a deep, dark seabed was then a coastal plain, a landscape of estuaries and exposed hills that early indigenous peoples would have known intimately. These communities were sophisticated hunters and gatherers, adept at utilizing maritime resources. The hypothesis is that these cairns could be ancient fishing structures, perhaps weirs or tidal traps built from stone to corral fish as the tides receded. Their organized rows might have funneled marine life into holding pools, a brilliant adaptation to a rich coastal environment. To understand the scale, imagine the terrestrial stone structures found across New England, like the enigmatic stone chambers and alignments at Mystery Hill in New Hampshire. The underwater cairns represent a potential extension of that same stoneworking tradition, but one that adapted to a shoreline that no longer exists. If these piles are indeed the work of archaic hands, their submersion is not an anomaly of sinking land, but a direct map of post-glacial sea level rise. They were built on dry land at the water's edge and were slowly claimed as the ocean filled the basin over millennia. This shifts the mystery from a geological what to a profound historical who. It asks us to reconsider the technological capabilities and maritime focus of early Americans. Were they not just passive inhabitants of the coast, but active engineers of it, shaping their environment with stone to harness the bounty of the sea? The silent cairns, if they are artifacts, represent a lost chapter of indigenous innovation, a sophisticated understanding of tides and ecology, now resting under 60 meters of Atlantic water. This vision of a deliberately shaped landscape now drowned leads to a site where the stonework is not in neat piles, but in a state of apparent and catastrophic collapse. The fortress walls of Kotor do not merely climb the mountain, they also vanish beneath the sea. This stunning bay in Montenegro, a fjord-like landscape of inlets and peaks, is a UNESCO World Heritage Site famed for its medieval Venetian defenses. Yet a closer look at the water's edge reveals a quiet mystery. Sections of the ancient and medieval defensive walls, along with stone gates and quays, now lie permanently submerged. Their drowning cannot be blamed on distant melting ice, but on the very ground they were built upon, ground that is slowly, inexorably sinking. The Bay of Kotor itself is a geological marvel, a submerged river canyon carved by ancient waterways and then flooded by the Adriatic Sea. The region sits within the complex collision zone of the Dinaric Alps, a landscape of dramatic karst topography, deep faults, and active tectonic movement. Geological surveys monitoring the area confirm a steady process of land subsidence, where the entire bay is tilting or sinking relative to the sea. This is a powerful example of relative sea level change, where local land movement outpaces the global average rise of the ocean. The water is not just coming up, the shore is going down. You can see this history written in the stones, specific sections of the seawalls near the old town, and the foundations of the Girdich Gate now rest below the waterline at high tide. They were not built to be flooded, they were built on solid land that has since retreated. A useful, though different, analogy is the Leaning Tower of Pisa. Its famous tilt is not a design flaw, but a result of building on unstable, subsiding ground. In Kotor, the entire landscape is the unstable foundation, causing not a tilt, but a slow, uniform descent. The reflective implication is profound. If a fortress in a stable-seeming bay is actively sinking due to invisible tectonic forces, how many other coastal ruins around the world are meeting a similar fate? Their submergence is not a global story, but a local geological biography, a silent dialogue between human stone and restless earth. This perspective of a landscape in motion prepares us for a discovery of staggering scale, where the sunken ruins are not measured in meters, but in hundreds of miles. The fortress walls of Kotor show a land in slow retreat, but to witness a landscape erased with breathtaking speed, we must look to a place now defined by its absence. The Persian Gulf today is a shallow sea, but 8,000 years ago, it was a vast, fertile river valley, a lost world that may have nurtured humanity's first steps toward civilization. During the last ice age, with sea levels over 400 feet lower, the Gulf was a dry basin, an extension of the Mesopotamian plain. It was not a desert. It was a lush oasis, a network of rivers and lakes fed by the mighty Tigris and Euphrates, which flowed through a single channel down the center of this exposed land, a waterway scholars call the Shat River. This was the Gulf Oasis, a paradise of freshwater and abundant resources, a perfect stage for early human communities. The anomaly here is not a single sunken structure, but the staggering scale of what was lost and the profound silence that now covers it. The flooding of this basin was not a slow creep, because the Gulf is so shallow with an average depth of only 50 meters. The post-glacial rise in sea level acted with dramatic efficiency. As the ocean breached the Strait of Hormuz, it did not gradually fill a deep bowl, it raced across a flat plain. Paleoclimatologists like Dr. Jeffrey Rose have modeled this event, suggesting that around 6000 BC, the rate of inundation would have been perceptible within a human lifetime. The shoreline could have advanced by over a kilometer every year, a relentless march of salt water that would have forced entire populations into a constant, generational retreat. We can still see the ghost of this drowned world on bathymetric maps. Sonar surveys clearly trace the submerged channels of ancient rivers, including the distinct path of the Karan River, which once flowed independently into the Gulf's inland lake. These are not subtle features, they are the stark blueprints of a vanished ecosystem. The potential for archaeological discovery here is immense, yet it remains almost entirely untapped. The political complexities and challenging conditions of the modern Gulf make systematic underwater exploration extraordinarily difficult. What clues we have come from the fringes. On the current coasts of Kuwait, Saudi Arabia, and Iran, archaeologists have uncovered settlements from the Ubaid period, dating to around 6500 BC. These sites, with their distinctive pottery and evidence of early trade, are not coastal villages. They are the last outposts, the final refuges of a people pushed inland by the advancing sea. Their presence on today's shoreline strongly suggests that their predecessors, their original homeland, lies farther out, now buried under layers of sediment on the Gulf floor. This geographical reality forces a revolutionary question. Could the very cradle of civilization, the foundation of the Sumerian cities that arose in southern Mesopotamia shortly after this flooding, have its true origins in that now drowned oasis? The flood myths that saturate Mesopotamian literature, most famously the Epic of Gilgamesh, speak of a great deluge sent by the gods to destroy humanity. These stories are not mere fiction, they are likely the cultural memory of a traumatic, real event, the loss of an ancestral homeland beneath the Persian Gulf. The reflective power of this idea is overwhelming. It suggests that the first great leap toward urban life may have been born not from a people discovering a river valley, but from a people fleeing a drowned one, carrying their knowledge, their social structures, and their stories of a lost paradise to the banks of the Tigris and Euphrates. Their greatest achievements on land may have been built upon the submerged foundations of a forgotten world. This concept of a foundational landscape lost to the sea leads to a site where the structures themselves seem to challenge the very laws of nature, resting where the physics of water and stone appear to have been rewritten. The ocean conceals its secrets not just on sunken plains, but in vertical shafts that plunge into darkness. These are blue holes, the silent sinkholes of the sea, and they are not merely geological wonders, they are among the planet's most perfect natural archives. From the iconic Great Blue Hole of Belize to the profound Dragon Hole in the South China Sea, these submerged caves offer a different kind of mystery. Their anomaly lies not in unexplained ruins, but in the pristine, layered preservation of time itself, capturing moments from epochs when their depths were dry land and their rims were bustling with life. To understand their power, you must first picture their origin. During the ice ages, when sea levels were hundreds of feet lower, these were terrestrial caves carved by rainwater dissolving the limestone bedrock. Their floors were dry, their ceilings intact, Then, as the glaciers melted and the oceans rose, the sea flooded the caves, filling them with quiet, anoxic water, water devoid of oxygen. This lack of oxygen is the key. It halts decay. Anything that fell into these holes, from a leaf to a lost tool to the remains of an animal, was entombed in a chemical vault, perfectly preserved in a sequence of sediments that chronicle the changing world above. Pioneering researchers like Dr. Kenny Broad have led expeditions into these abysses, using advanced diving techniques and core sampling to read these submerged history books. They extract long cylinders of sediment, and within those cores they find a stratified diary of climate and life. Layers of pollen tell the story of shifting vegetation, from dry scrubland to lush forest as the ice retreated. Fossils of extinct species like giant ground sloths or saber-toothed cats appear in strata that correspond to periods when the sinkhole was an open pit trap on a dry landscape. And sometimes nestled within those layers are the subtle, profound signs of human presence. A shard of Mayan pottery found in a blue hole near a coastal settlement suggests ritual offerings or accidental loss when the water table was far below. These holes, positioned near ancient coastlines, acted as inadvertent collection points for a passing world. One of the most stunning examples is the Hoyo Negro sinkhole in Mexico's Yucatan Peninsula. Here, divers discovered the complete skeleton of a young woman nicknamed Naya, who lived over 12,000 years ago. She represents some of the earliest known human remains in the Americas. Her resting place was not a burial but a tragic accident. She likely fell into the deep pit when it was a dry cave, and the rising waters later sealed her in a timeless, protective embrace. The conditions preserved her bones and even her DNA, offering an unprecedented genetic snapshot of the first peoples to cross into the New World. This single discovery rewrote chapters of human migration. So we must pause and ask a reflective question. If one blue hole can hold the story of a life from the dawn of human presence in a continent, what other lost chapters of our collective prehistory are sealed in the layered, silent depths of thousands of similar marine sinkholes around the globe? Each one is a potential time capsule, waiting for the light of a diver's lamp to reveal its stratified secrets. From these vertical wells of deep time, our gaze shifts to a horizontal mystery etched across the seabed, a line so long and straight it seems to defy the chaos of nature. The silent depths of the Sea of Galilee hold a monument of staggering effort. Resting 10 meters below its freshwater surface is a colossal, crescent-shaped wall of stone, a structure so massive it has been called the Sea of Galilee Monster. Discovered by sonar and studied by a team led by Professor Issyk-Kul, this is not a natural formation. It is a deliberate construction from the early Bronze Age, a pile of uncut basalt boulders weighing an estimated 60,000 tons. To picture that scale, imagine a stack of stones equal to the weight of 10,000 elephants, carefully placed in a curve 70 meters long and 10 meters high. This is a project of profound communal labor, built over 4,000 years ago on what was likely a dry lakebed during a period of severe drought. The central mystery is not how it sank, for the lake's levels have always fluctuated with the regional climate. The haunting question is why it was built there at all. Why would a society with limited technology commit generations of effort to pile stones in a location they knew would inevitably flood when the rains returned? The theories proposed by archaeologists offer glimpses into a lost mindset. It could have been a practical fishing installation, a kind of giant weir or fish nursery. It might have been a ceremonial site, a sacred crescent aligned with the heavens or the surrounding hills. Some even suggest it could be a burial monument for an important leader, a permanent marker in a transient landscape. Professor Marco emphasizes the sheer logistics, noting the stones were sourced from over a mile away and transported without wheels or draft animals, a testament to social organization and shared purpose. A useful comparison lies far to the west at Silbury Hill in England, an artificial chalk mound built around the same era. Both represent an enormous investment in altering the landscape for a purpose that remains, to us, beautifully obscure. The Sea of Galilee structure forces a reflective shift in how we view ancient ingenuity. It asks us to consider that what we might see as a vulnerable, flood-prone basin, they may have seen as a spiritually charged center of their world, worth marking with a mountain of stone, even if they knew the waters would one day reclaim it. This willingness to move mountains, quite literally, to fulfill a cultural vision, finds a parallel in an even more audacious endeavor, where the stones for a sacred city did not come from a nearby hillside, but had to voyage across the open sea. Herod the Great's ambition was written in stone against the sea. At Caesarea Maritima, he commanded a harbor to rise where nature had provided none, a monumental feat of Roman engineering meant to announce his power to the world. Today, the archaeological park presents a stunning paradox, where the remains of that glorious port now lie broken and partially submerged, a testament not to the ocean's patient rise, but to the ground's sudden betrayal. The anomaly here is not a mystery of sinking land masses, but a clear case of engineering ambition outpacing geological reality. Herod's builders constructed an artificial harbor, one of the largest of the ancient world, by sinking enormous wooden forms into the sandy seabed and filling them with a special Roman concrete that could cure underwater. They erected mighty breakwaters to create a calm anchorage, and along the shore they built quays, warehouses, and a magnificent shipyard. For a time it worked brilliantly, a bustling gateway to the eastern Mediterranean. But the foundation was fatally flawed. The entire complex was built upon an unstable substrate of soft sand and sediment. The immense weight of the stone structures, combined with the relentless pulse of seismic activity in this region, initiated a slow, relentless process of subsidence. Harbor archaeologists studying the site point to a specific, catastrophic mechanism: liquefaction. During earthquakes, the water-saturated sand beneath the foundations would momentarily lose its solidity, turning into a liquid slurry. The heavy stone blocks, suddenly without support, would shift, crack, and sink into the mire. You can see the results today beneath the clear water. The outer Herodian breakwater, once a proud barrier against the waves, now lies in a scattered, submerged ruin. A colossal statue base, meant to hold a figure of the emperor, rests tilted on the seafloor, a silent monument to the ground's failure. The sophisticated shipyard and its loading quays, engineered for efficiency, are now underwater features, their precise geometry distorted by uneven settling. This was a geotechnical defeat. The sea did not rise up to claim Caesarea's harbor. The harbor sank down to meet the sea, a victim of its own immense scale on an incapable foundation. A modern parallel can be seen in the constant struggle to build on soft deltaic soils, from Venice to New Orleans, where the ground itself is a fluid, shifting adversary. So we must ask a broader question that echoes from this failed Roman port. How many of antiquity's greatest engineering triumphs, its pyramids, its temples, its sprawling cities, were ultimately compromised or doomed not by war or neglect, but by a simple, unyielding truth of physics, that the earth beneath them could not forever bear their weight? This story of a harbor defeated by its foundation leads us to consider one that succeeded through perfect concealment, a port that did not fight the geology but disappeared into it. The giant statues of pharaohs and gods did not topple in battle, but in a slow, silent slide into the mud. At the mouth of the Nile, where the great river meets the Mediterranean, the legendary port of Thonis-Heracleion was not merely flooded, it was consumed. Resting 7 meters beneath the waves of Aboukir Bay, this city represents one of the most dramatic rediscoveries in underwater archaeology, and its fate reveals a flaw in the very foundation of civilization. For centuries, Thonis-Heracleion was known only from ancient texts, a major gateway where Greek traders entered Egypt and paid taxes to the pharaoh. Then, in the late 1990s, a team led by underwater archaeologist Frank Gaudio began to map the bay, and their instruments revealed a sprawling metropolis, complete with grand temples, harbors, and neighborhoods, all perfectly preserved in the sediment. The artifacts recovered are breathtaking, from a 5-meter-tall statue of the god Happy to towering stelae inscribed with royal decrees, and even delicate gold coins that shimmered after 2 millennia in the dark. Yet the true story is told not by these treasures, but by their posture on the seafloor. Many of the colossal statues and temple columns were found tilted at severe angles, as if the ground beneath them had turned to liquid and they had slowly, inexorably, slid into their current positions. This is the critical clue. Thonis-Heracleion was not a victim of the sea rising from afar, but of the land collapsing from within. The city was built on the unstable, waterlogged clays of the Nile Delta. This ground is inherently fragile, a saturated mixture of silt and clay that can behave like a fluid when subjected to stress. The primary catalyst for the city's drowning, researchers like Gaudio believe, was likely a major earthquake or an exceptionally severe Nile flood around the 2nd century BC. Such an event would have triggered a process called soil liquefaction. The intense shaking or sudden saturation from floodwaters increases the water pressure between the sediment grains, causing the solid ground to temporarily lose its strength. Imagine building a sandcastle too close to the tide, where the base becomes saturated and the entire structure slumps into a shapeless mound. On the scale of a city, this meant that the heavy stone temples and monuments acted like weights on a waterbed, sinking into the destabilized clay. Entire districts would have subsided unevenly, canals buckling and walls cracking, as the Mediterranean waters rushed in to fill the newly created basins. This was not a single, instantaneous plunge, but a rapid series of collapses over perhaps a generation, a relentless sinking that made the city untenable. A powerful modern parallel exists in New Orleans, a city also built on deltaic soils. There, engineered levees and drainage systems have caused the organic soils to dry out and compact, resulting in large areas of the city sinking below sea level, a constant reminder of the precariousness of building on such foundations. The reflective question posed by Thonis-Heracleion is therefore urgent and profound. How many of the world's great delta cities, from ancient times to our own bustling modern megacities, are sitting on a similar geological time bomb? Their survival depends not just on holding back the ocean, but on maintaining the delicate, unseen balance of the ground beneath their streets. From this story of a civilization sinking into its own foundation, we ascend to a place where the water is held not by a delta, but within the fiery heart of a mountain. High in the Tian Shan Mountains, a lake holds the memory of shifting shores. Lake Issyk-Kul in Kyrgyzstan is a vast, deep basin of slightly saline water, a brilliant blue jewel encircled by snow-capped peaks. For centuries, local legends have spoken of a sunken city beneath its waves, a place sometimes called the Kyrgyz Atlantis. These are not just campfire tales. The anomaly here is a powerful reminder that the sea is not the only water that can claim a civilization. The lake's level dances to its own rhythm, dictated by the delicate balance of mountain snowfall and evaporation, completely independent of the world's oceans. Over the past 2,000 years, Issyk-Kul has been both significantly higher and lower than it is today, its shoreline advancing and retreating across the valleys like a slow, breathing tide. This local hydrological heartbeat has repeatedly reshaped the human geography around it, drowning some settlements and exposing the ruins of others. Archaeological surveys along the lake's modern edges have yielded compelling evidence of this lost coastline. In shallow waters and on newly exposed mudflats during dry periods, researchers have found the remnants of hearths, the foundations of stone walls, and scattered pottery shards. These artifacts point to habitation from different eras, from the nomadic Scythian tribes known for their intricate gold work to later medieval settlements that thrived on the Silk Road trade. The most persistent legend speaks of an Armenian monastery, said to hold the relics of Saint Matthew, that was lost when the waters rose. While no submerged monastery has been conclusively found, the story itself is a cultural compass, pointing to a time when the lake shore was in a different place and a Christian outpost could have existed in this remote, mountainous heart of Asia. To understand the scale of this change, consider other great inland seas like the Caspian. Its shoreline has migrated hundreds of kilometers over centuries, stranding ports far inland and drowning others, forcing entire populations into a slow migration. Issyk-Kul operates on a similar, if smaller, principle. A prolonged wet period in the mountains sends more meltwater into the basin, causing the lake to swell and expand over decades. A shift to a drier climate causes it to recede, revealing the buried past. This dynamic environment challenges our view of history as something fixed upon a static map. It asks a reflective question that echoes far beyond these mountains. How does our understanding of nomadic routes, trade networks, and the rise of settled cultures transform when we begin to chart the ancient, now drowned, shores of the world's great interior lakes? These were not barren edges but vibrant corridors of life, places for winter camps, seasonal markets, and sacred sites, all subject to the silent, patient will of the climate. The story of Issyk-Kul is one of adaptation, of cultures living in dialogue with a landscape that was itself in motion. From this high-altitude basin of independent change, our search descends into the deep ocean, where a modern sonar detection presents an enigma stripped of all cultural memory, a shape that defies any simple explanation. From the singular enigma of a sonar ghost, we zoom out to a view encompassing the entire planet. Modern technology has given us a map of the ocean floor in unprecedented detail, a tapestry woven from satellite altimetry and sonar data from countless research vessels. And on this vast digital canvas, a startling pattern emerges, not of one mystery but of millions. Scattered across every ocean basin, at every conceivable depth, are features that catch the eye and ignite the imagination. Perfect circles, long straight lines, grids of intersecting ridges, and geometric shapes of bewildering regularity. This is the 28th category of anomaly, not a single site, but a global phenomenon of seafloor patterns. The sheer volume is staggering, with over 70% of our planet covered by water, and only a fraction of that seabed explored with high-resolution sonar. We are confronted with an ocean of questions. Are we looking at the scattered ruins of a forgotten human past, a planet-wide archaeological site of unimaginable scale? Or are we simply witnessing the breathtaking and often unnervingly precise artistry of natural geological processes? This is the core dilemma of the digital age of discovery. Platforms like Google Earth, which incorporate public bathymetry data from missions like NASA SRTM, have turned anyone with an internet connection into a potential deep-sea explorer. A global community of citizen scientists and independent researchers now spends hours scouring these digital depths, flagging peculiar formations and sharing them online. The excitement is palpable, for every strange circle could be the next Yonaguni, the next gateway to a rewritten history. Yet marine geomorphologists, the scientists who study the shape and origin of the seabed, urge a crucial perspective. They bring a vital framework to this sea of speculation. The vast majority of these intriguing features have well-understood natural explanations, those perfect circles. They are often pockmarks created by methane gas bubbling up from sediments or the collapse of underground cavities. The long, parallel lines can be sediment waves, formed by deep ocean currents flowing over a muddy bottom, much like sand dunes in a desert. Grid-like patterns might be the result of icebergs scraping the seafloor during the last ice age, or the tracks of modern fishing trawlers dragging heavy equipment across the bottom. Even the straightest lines can be artifacts of the survey process itself, the track lines of the research vessel's sonar. The process of distinguishing a potential ruin from a natural wonder is called ground truthing. It requires sending a remotely operated vehicle or a submersible down to physically examine the site, to take samples, to look for tool marks or cultural artifacts. This is expensive, time-consuming, and dangerous work. For every one anomaly that gets investigated, millions remain as pixels on a screen, their true nature suspended between possibility and geology. A powerful terrestrial analogy is the Badlands Guardian in Alberta, Canada. From a satellite, this natural geological formation looks unmistakably like a human head wearing a traditional feathered headdress, so precise it seems carved. Yet on the ground, it is revealed as a beautiful but entirely natural hill, shaped by wind and water erosion. The ocean floor is a museum of such illusions, sculpted on a continental scale by processes we are only beginning to fully understand. So we arrive at a reflective question essential for our time. In an age where we can see so much yet physically touch so little of the deep sea, how do we responsibly nurture our sense of wonder about a hidden human past, while rigorously honoring the incredible creative power of natural forces? The answer lies not in choosing one narrative over the other, but in developing the patience and methodology to listen to what the seabed is actually telling us. This disciplined approach prepares us to examine our final sites, which synthesize the grand themes of this entire journey, moving from mysterious shapes to profound cultural absences.